Hi, everyone, and welcome to this presentation about autonomous systems and the implementation of innovative technology. I'll just try to see if I can move the pictures of everyone here, so it's a bit in a way. My name is Therese Tärnholm, and my background is from the Swedish Armed Forces in the Navy. I started my PhD studies here at KTH in September of 2019, so I haven't come that far as Joanna. 80% of my doctoral studies is at KTH, close to the SMaRC project, not in it. I will follow the technological development as close as I can, because this is something that the Swedish Defense Forces are also in some way part of the project through FMV and so on. So the 20% that is the rest is within the Swedish Navy staff in research and development. My latest project there was in the main study of how the Navy will look in 2045. So looking forward and seeing if autonomous system can be a part of it. I'm also connected to the researchers some researchers at Swedish Defense University through my supervisor, Hans Livong, and that is mainly the Department of Defense Systems. As we talked about before, I'm not in the SMaRC project, and that also means that I'm not as technical as the ones in the SMaRC project. My studies started more with the concept development thoughts concerning innovative technology, and to get them into an organization like the Swedish Armed Forces. And I will try to present 3 studies, past, present, future, starting with military organizations and emerging technologies. Just mentioning a case study that I will perform within the Swedish Navy, and some ethical and legal aspects of using autonomous underwater vehicles and systems. Starting with the first one, military organizations and emerging technologies. This is based on a multidisciplinary literature study within different research areas, such as autonomous systems, of course, concept development in general, ethical and legal aspects of using autonomous systems, but also war studies at the Defense University to see what kind of implications innovative technology has within the organization and the implementation of it. The armed forces is no longer as technological driving as they used to be, but now more technological using. And that could also have some kind of implication on how they are able to address and embrace new technology. Coming to the second point of the first sets here is the hierarchical layers. Talking about defense forces and armed forces, often, the hierarchical layers come into mind because that's more or less the setup for it. This can come in different layers, not only the obvious rank, but also the gender part, age, and if you're military or civilian within the organization. The hierarchical mindset can impose a negative impact on how technology is presented into the organization. You can show some tensions between the project set out to handle new systems and technology with the line organization that handles the more day-to-day concerns. You can see that there has to be some kind of balance within the design organization between the scholarly work and the ones that know how to use the system. Some literature talk about the balance between the master and the genius. The balance, to use new technology in an efficient way within the armed forces is to have the technology find its place within the armed forces, so that it satisfies both organizational and capability needs. And then we have one word that is very important for looking at how armed forces perform, just capability. In Australia, they say capability is the capacity or ability to achieve an operational effect. NATO has more extensive explanation to say the ability to create an effect through employment of an integrated set of aspects. And then they talk about the doctrine, the organization, the training, the material being the technological system, leadership development, personnel, facilities, and interoperability, showing that to create some kind of capability within the armed forces demands so much more than the technical system. I also talk about the maritime autonomous systems, which be a more collection word for all autonomous and unmanned systems in the maritime sphere, being both underwater and surface. The research here is very extensive on the technological side, not so extensive when it comes to multidisciplinary and social aspects of it, such as organizational thoughts, ethical and legal aspects, but it's coming more and more. And I will discuss some aspects of autonomous systems compared to, compare the maritime domain to the other domains we have in air and ground. Is there any conclusions you can draw from problems and solutions that they have? Also looking at differences between the maritime domain, being differences in technical parts, but also legal parts with underwater and surface systems. And when you talk about autonomous systems, you often come to organizational trust in a system. The system needs to be efficient and safe. And how should you do that? How should you know that if you can't see the system, for example, being underwater, or if the system itself are making decisions that you can't really control? I also talk about social technical systems and system of systems. They talk about often the same thing, but with different vocabulary, which means that they can't or don't want to draw conclusions between the different research areas. A social technical system can be seen as a hybrid system between natural and social science, including the organization, people, and technology. Whereas the system of systems can be likened to a composition of underlying systems that together increase in complexity and functionality, and then together form some kind of capability. Armed forces with its units, I tend to see as a socio-technical system with its organization, the personnel, the different units, and in some way you have to have the boundaries to other systems as well. It is also a system of systems that produce and enable desired capabilities, and both of these are largely defined the integration within other systems or the interface between systems. And that comes to the question, what should be within the boundary? Is it just the Navy? Is it the armed forces? Is it the armed forces together with other authorities such as research agencies and procurement agency? Or should even the industry be within this boundary? And I find it that it's very depending on what phase you're in the technical system. Is it design phase, for example? Of course, the industry should be a part of it. And as we see it right now, it is not as involved as it could be and perhaps should be right now. Finally, in that part, I talk about concept and capability development. and this is the area least research with a military focus. This is where you often start when you're looking at new concepts at concept development part. Within armed forces, you often use a method called concept development and experimentation, set out from NATO, and that is to form some kind of link between national strategy and actual capabilities in the different armed forces. Yes, the term capability-based planning is something that are more and more is more and more used compared to what is formerly known as threat-based planning. And this shift is to think more about defense capabilities than weapon systems itself, since the capability is something that can be solved with a composition of different systems. This comes clear when you look at military capability as something that most of the times outlives the duration of the individual systems, which makes it more efficient to look when you're developing systems in a capability life cycle instead of a system life cycle that is often discussed within systems engineering, for example. If you could continue to the capability thought, I will perform a case study in the Swedish Armed Forces. I'll also just highlight again how the capability is defined by NATO as the ability to create an effect through employment of integrated set of aspects. Talking about the doctrine, the organization, the training, the material, leadership development, personnel, facilities, and interoperability. Interoperability is in the NATO version, not in the US version, since interoperability is very important when you're dealing with different states and different organizations. When you're looking at capability development, you can see it as the design process. Have you seen system engineering? You probably recognize the different phases. You're starting with some kind of strategy and concept where you identify the capability needs. You continue into some kind of risk mitigation and set your requirements where you define and decide the capability solutions. You come to a part where you acquire the capability and introduce it into the service, and you have the support of the capability through its life and also in the disposal phase. And the case study I will perform will be on different units and different levels of the Swedish Armed Forces. The questions are concerning the development and implementation of new and maybe organizational changing technology. They will be divided into different stages of the design process, and this is to see how the different parts of the units and also how they are involved in the design process. Do they have integrated planning with other units? Do they have integrated planning with the headquarters, or are they more or less excluded from the design process? Hopefully this will end up in some kind of list of problems or areas that could be dealt with within the organization to help present an easier way to implement new technology. After this, I will talk a little bit about the ethical and legal aspects of using autonomous underwater vehicles or systems. When you talk about autonomous systems, you also often talk about some kind of trust in the system, as I mentioned before. And often when you say trust in the system, you consider man in the loop being something that is quite trustworthy. And in an autonomous system, you you're not supposed to have a man in the loop, at least not during the operational phase. So how do you deal with it then? Then it comes up in the literature and discussing very heavily the meaningful human control, which mainly comes down to accountability, moral responsibility, and controllability of the system. This must be present during all the different layers, as I presented here, the technical, socio-technical governance. How the system is designed, how the socio-technical system is set up, and also to a well-supported entity of legal and ethical considerations. It does not only demand that the system itself is controllable in a technical way, but also that the organization is ready and willing to take responsibility and control, which is not always the case. Some parts of these different layers that I will talk about, the technical, the socio-technical governance part. For example, navigation. Questions that can come up here is, what methods will you use? Are there different methods depending on where you are moving? Is it deep, shallow water? Are you close to enemy borders, for example? Will you use different systems for this? Communication, how will the system communicate? For example, if you have surveillance gathering data, how should you present these without presenting where your systems are at the moment? And endurance could also affect how you use your system. For example, how far away can it be launched from the operational area? Socio-technical part, it's obvious that it's deal with the organization, how it's put together. Are you using an autonomous system together with other platforms? Are the platforms qualified or unqualified? What kind of personnel do you need to handle this system? But it's also a form of tactics, the social technical part. How can you use the system so it fits in the best way into the organization? Is that the size and the different technical entities of the system significant for any type of tactical moves? Should the system move in swarms instead of single-handedly, so they can, share tasks between them, for example? And the governance layer, that's more the outer layer that ethical and legally manage the rest of the systems. And here I have some examples of the maritime legal parts. The first one being the UN Convention of the Law of the Sea. This provides some kind of rules for freedom of navigation. It's allowing, for example, innocent passage through other territorial waters. For underwater systems, this is interesting because if you're supposed to do innocent passage, you're supposed to be surfaced. So that's also one of the parts of using the system, being covert. If you need to surface, you're not covert anymore. The next one being Convention of on the International Regulations for Preventing Collisions at Sea. Here comes an interesting discussion on how you should see autonomous systems. Are there vessels? Are there weapons? Or are there devices? And depending on how you categorize the system, it comes under different laws and regulations. But they can still manage to agree on that the system should be able to avoid posing a threat to other vessels. When dealing with military systems, you also have the law of armed conflict. And in autonomous systems, if they should be fully autonomous, they deal with mainly two parts of it, the distinction part and the proportionality part. They should be able to distinct different targets from each other, and also distinct where and when I'm supposed to use what kind of force towards which target. in this study, I will do a small case study. 2 different systems, one armed system and one armed system, will be performing different tasks. The armed one will move from Stockholm to Umeå to present some kind of force on some kind of on some part of the harbor structure. Also be able to receive feedback or send feedback on whether the mission has been successful or not. The unarmed system will also transfer from Stockholm to Umeå, and it will do that for intelligence gathering, then return to a safe place to hand over the gathered information. And if you look at this picture, this is where they will be moving. This is the Botnia Gulf. You have populated regions on both coast sides here. You have, this is a picture from the AIS from yesterday. You have commercial traffic within the areas, which means sea lines of communication. You have brackish water with varying depths. What could that have an effect on buoyancy systems, and what kind of navigational aids you can use? You have some navigational narrow straits, for example, here between this Southland country and Åland. You have the territorial waters that you have to be aware of, and you have a demilitarized zone surrounding Åland, where no military objects are supposed to be present. Perhaps it's a little bit more visualized here, the different territorial parts. I can't see my, there it is. So here is Åland. Here you have straits and territorial waters. The mission will last for 3 weeks without human interaction. The system could be should be able to handle every different situation that it is presented to. And if you look at some different parts of the governance layer, the outer layer, the ones controlling legal and ethical parts, I have done some kind of examples. For example, with the first one, the law of the sea. The navigational performance of the system itself need to be very accurate to be able to know when you are within or close to territorial waters, depending on where you should be. It also shows you where you need to surface, for example, if you're going in an innocent passage. The navigational performance also makes you know if you have the right destination, for example. Reconnaissance from the wrong harbor, it's bad enough, but the use of force on the wrong target is much more severe. With obstacle avoidance, you have other vessels to take into consideration, but you also need to take other civilian values into consideration, for example, fish nets and other algae farms, for example. But you also, if you're not able to avoid fishing nets, you can also risk the operation since your own system will be stuck. When you use it in a military aspect, the law of armed conflict, of course, could be present. And here you can see that, for example, recognition and moral deduction is something that becomes very important when you see distinction and proportionality. Some say that to be able to handle this, autonomous systems are not as yet ready to make those moral and ethical judgments. I will just have a small brief discussion on ethics with that last line on the page. Ought we hold machines to a higher standard than we have yet to achieve ourselves? They also talk about the attention given to blame far exceeds that given to praise in the surrounding of that mistakes made by a non-human entity is judged far worse and severe than one made by humans. So as a final thought to this, how much more do we need to trust the system, the autonomous system, than our fellow decision maker to be able to operationalize this system? This notion could have an implication on the issues of trust in the system, which makes it hard to see the benefits with the system in mind, even how well it performs in other parts. This is because the benefits are overridden by any possible negative effect the system may impose. This is short, a presentation of what you can look at with the technical system in focus, but there are so many other parts to handle before you can implement it, especially into an organization like Defense Forces, especially if you're using it as an armed system. So thank you very much, and if you have any questions, just go ahead.